Alright, good morning guys. Last video for the year of 2019 before we close up here shortly. So we had a bit of a request here on Facebook from a Denny Masconi, and he's sort of questioning and asking, how is it possible that two of our 100 amp hour batteries in parallel can provide such a big current, current supply to, like, for example, a 3000 watt inverter. So we just set up this quick test today. We've got two of our 100 amp hour batteries off the shelf. Now, these have not even been balanced. They're straight out of the box, and you can see they're equalizing there at 1.7 amps. Okay, so these batteries have not done 10 cycles and haven't been connected in parallel for a week. They're basically off the shelf and they're just leveling off now a little bit. So this is a good test because these are not in balance, and we're going to load these up to 200 amps on the inverter, and we're going to see what the current difference is between the two batteries. Now, what I want to explain is why the DCS batteries can provide such a high current discharge and charge capability in parallel. There's two main factors. One is the integrity of the cells. Okay, with very closely matched cells between battery packs and our very tight quality control, we can theoretically get very close to a very even current split. Okay, the second most important factor is obviously the battery management system. It is very capable, as you guys that already have our products are probably well aware that when we say 150 amps continuous, that is 150 amps continuous, and we allow surge well beyond that. So these batteries, you're never going to get a 50-50 even current split. It's impossible. But if you're within 20 or 30% after a lengthy load, that is more than enough supply or overcharge that our battery management systems can easily cope with. Okay, so that's the most important two factors. The other factor is obviously the balancing boards. So our batteries are balanced at an extremely tight regime, and with those battery packs being properly balanced and correctly aggressively balanced on every single charge, when you do load up an inverter, you're going to get a nice even current split. Okay, so let's do the test now and we'll show you. So we've plugged a bunch of appliances in here. We're trying to get as much current as we can. So I'm going to clamp meter the main connection here, the main power circuit here to the inverter. We're going to turn this on now. We've got some fan motors, some lights, some heating equipment. We've got quite a bit of gear. So 186 amps we're drawing now on the inverter. So 186 divided by 2, we're looking around about 90 amps or close to 100 amps per battery. So let's go ahead and see what one battery is drawing now. Okay, one battery is drawing 87 amps and the other one's going to be drawing the difference there at 100. Okay, so nearly 90 and 100 to supply that 190 amp load. Now we're going to keep clamp metering the battery that's got a high current. Okay, and we can see how much harder it's got to work. Okay, slowly climbing. Okay, so we're pulling 200 amps now from two of our 100 amp hour batteries, which run a 150 amp battery management system. And you can see the battery that's got more juice in it at the moment, because I haven't equalized, is this one, and it's sitting there at 103 amps very comfortably. Now that is nowhere near our continuous 150 amp rating of the battery management system, which can surge up to 200 amps easily. So that is why on just two of our 100 amp hour batteries you can run a 3 kilowatt inverter at full power without any issues whatsoever. Okay, so there's your proof there. Hope that explains a bit more about the technology inside our battery packs and why our batteries are quite different and unique compared to all the other stuff in the industry. Okay, so 104 amps. Now this one's dropped to, sorry, clamp metered that. Let me just clear that. We don't want to be holding. There we go. Okay, so 85, 86 amps, 100, 105. Okay, so very close. As a percentage, that difference is tiny. Now, still sitting at 190 amps. So 190 amp load, nearly 90 amps on one battery and 100 on the other. 105. Again, that is very even for two batteries still in the boxes off the shelf that have not even been equalized. Okay, so there's no way you're going to get any shutdown issues or anything like that. So there you go, guys. Thanks for watching. Have a great Christmas and a break. Have some fun out there with all your toys, and I'll catch you in the new year.